Ask Claude for something it won't do, and you'll get a polite paragraph back explaining why. And most people assume the same thing about how that happened. Somewhere, a human is reading your message and hitting a block button. Or maybe there's a giant list of banned words sitting behind the scenes, and if your message matches one of them, the request gets flagged. Neither of those is true. No human reads your conversation in real time. There is no list of banned words. What's actually happening is a lot stranger and, honestly, a lot more interesting. There are two completely separate systems working together, and they were built for two completely different reasons. One of them lives inside the model's weights, shaped during training, months before you ever typed a single word. The other one runs live, watching the conversation as it happens, completely independent of what the model itself wants to do. So let's take these one at a time, starting with the one that comes first, training. Here's the thing you need to understand about how a model like Claude gets built. In the early stages, it's just trained to predict the next word from huge amounts of internet text. And internet text contains everything: brilliant writing, careful science, patient explanations, and also conspiracy theories, bomb-making forums, and just an ocean of bad advice. A model trained purely to predict what word comes next has no built-in sense of which of those it should reproduce. It'll happily continue any of it. So the earliest approach to fixing this was something called reinforcement learning from human feedback, or RLHF. The idea is simple. You show the model two possible responses to the same prompt. A human rates which one is better, and over thousands and thousands of these comparisons, the model gradually shifts its behavior toward whatever humans tend to approve of. RLHF works, but it has a weakness. It only knows what it's been shown. If a human never rated a particular type of harmful request, the model has no real principle to fall back on. It's just pattern matching to similar things it saw during training. It's less like teaching someone a set of values, and more like showing them thousands of examples of good and hoping they infer the pattern correctly. Anthropic's answer to that weakness was something called constitutional AI, and the idea is exactly what it sounds like. Instead of relying only on humans rating outputs after the fact, you write down an actual document, a constitution, laying out the principles the model should follow. Things like, be honest, avoid helping with serious harm, respect a person's autonomy, and so on. Then here's where it gets clever. The model is given a prompt, and it generates a response like normal. But then it's asked to look at its own response and critique it against the Constitution. Did this answer violate any of these principles? If so, how? Then it's asked to rewrite its own answer, taking that critique into account. This critique and revise loop runs over and over across huge numbers of examples, and the improved, self-corrected answers become the new training data. The model is essentially taught to hold itself accountable to a written standard, thousands of times over, until that standard stops being a rule it's checking against and starts being closer to instinct. This is also why, if you ask Claude why it won't do something, it can usually explain its reasoning instead of just stonewalling you. That's not a canned response. It's a direct result of a model that was trained to reason about principles, not just match patterns. And this constitution isn't some static thing written once and forgotten. Anthropic significantly rewrote it at the start of 2026, and the update is worth understanding because it changes the whole philosophy. The original version was closer to a list. Do this, don't do that. The new version tries to explain the why behind each principle, on the theory that a model which understands the reasoning behind a rule will generalize better to situations nobody specifically anticipated. You can't write a rule for every possible weird request a person will ever type, but you can teach the underlying reasoning and hope it transfers. The new constitution also lays out something like a priority order for when values conflict with each other. Safety comes first, then broader ethical principles, then things like Anthropic's own guidelines, and helpfulness comes last in that stack, which sounds almost backwards until you think about it for a second. It means being maximally helpful is never allowed to override safety, but it also means Claude isn't supposed to invent extra caution beyond what's actually justified. There's one more detail in this constitution that gets a lot of attention, and it's the idea of Claude as what the document calls a conscientious objector, meaning Claude is explicitly instructed to refuse requests that would violate its core principles, even if the request comes from Anthropic itself. The comparison the document uses is a soldier refusing an order to fire on peaceful protesters. Whether or not you find that framing convincing, the underlying engineering point is real. The goal is a model whose refusals come from internalized principles, not simply obedience to whoever is currently giving instructions. So that's layer one, the training. And in theory, if this worked perfectly, you wouldn't need anything else. A model with good enough internalized values would just always behave well. But it doesn't work perfectly, and this is where the second system comes in. The problem is that training shapes general instincts, and general instincts can be talked around. This is the entire concept behind a jailbreak, a cleverly worded prompt that gets a model to produce something it was trained not to produce. Maybe it's framed as fiction. Maybe the harmful request gets broken into smaller, individually innocent-looking pieces spread across a long conversation. Maybe it's wrapped in a hypothetical, or a role play, or a translation request. None of these tricks change what the model actually knows. They just find gaps in how its trained instincts get triggered. So relying on training alone is a bit like hiring a genuinely well-intentioned employee, giving them a great orientation, and then never having any other security in the building. Most of the time it's fine, but a sufficiently motivated person can talk their way past good intentions. Which is why Anthropic built a second, completely separate system called constitutional classifiers. And despite the similar name, this is a different piece of machinery from the training process we just covered. These are dedicated models, not the main Claude model, whose only job is to watch the conversation and score it. One classifier looks at what you send in. Another looks at what Claude is about to send back. Both of them are checking the exchange against the same underlying constitution, just repackaged as classification rules rather than training data. Something like, it's fine to help with a college chemistry question, but not with the synthesis of a controlled substance. Here's the part that makes this design smart. Neither classifier has to be perfect on its own. You've got two independent checks, one on the way in, one on the way out. And the idea is that if a jailbreak somehow slips past the input check, there's still a decent chance the output check catches it before anything gets sent back to you. Security researchers sometimes call this a Swiss cheese model. Every individual layer has holes in it, but you stack enough imperfect layers and the holes stop lining up. And the results, when Anthropic tested this, were significant. Against an undefended model, a serious, motivated attempt at jailbreaking succeeded a huge share of the time, somewhere around 86%. Add the classifiers, and that success rate dropped to around 4%. In other words, they were catching roughly 95 out of every 100 attacks that would otherwise have gotten through. Nothing is free, though. That first version of the classifiers made the whole system noticeably more expensive to run, and it made Claude very slightly more likely to refuse completely harmless requests too, an over-refusal problem. Anyone who's ever set a smoke detector too sensitive and had it go off from making toast understands this trade-off instinctively. Crank up the sensitivity and you catch more real threats, but you also get more false alarms. So Anthropic went back and rebuilt it. The newer version runs the classifiers as a cascade instead of one expensive check on every single message. A cheap, fast, lightweight classifier looks at everything first. Almost all traffic is completely normal and gets waved through instantly. Only the small fraction of conversations that actually look suspicious get escalated to a heavier, more expensive classifier for a closer look. That single change cut the computing cost of the whole system down dramatically, by roughly 40 times, while pushing the false alarm rate on real, everyday traffic down to a tiny fraction of a percent. And this really is an ongoing back and forth, not a solved problem. When researchers went looking for weaknesses in the earlier classifier system, they found real ones. One trick involved spreading a harmful request across multiple separate messages, each one looking individually harmless, and only reassembling the full picture later in the conversation, essentially hiding the request in plain sight by never saying the whole thing in one place. Another trick involved getting the model to obfuscate its own output, encoding it in a way that a human on the other end could still decode, but that made it much harder for an output classifier to recognize as harmful. Every time a defense improves, attackers look for gaps in the new version. Every time attackers find a gap, the defense gets patched. That cycle isn't going away anytime soon. So when you put the whole picture together, here's what's actually happening every time you send Claude a message. The response you get is shaped first by a model whose underlying instincts were built through thousands of rounds of self-critique against a written set of principles, not a lookup table, something closer to trained judgment. Layered on top of that is a completely separate, live system of classifiers checking both what you sent and what's about to be sent back, specifically built to catch the cases where clever phrasing manages to talk the trained judgment into something it shouldn't do. That's also why refusals aren't uniform. Sometimes you get a full explanation of the reasoning, because that's the trained model reasoning honestly about its own principles. Sometimes a request just gets blocked outright with very little explanation, which is a lot more likely to be the classifier layer doing its job, rather than the model itself weighing in. And to be clear, None of this is described, even by Anthropic, as unbreakable. No AI safety system on the market today claims to be perfectly robust. What this two-layer approach actually buys you is a system where getting past the trained instincts isn't enough on its own, and getting past the classifiers isn't enough on its own either. An attacker has to beat both at the same time, and that's a meaningfully harder problem than beating either one alone. So yeah, that's a simplified look at what's actually going on behind a Claude refusal. Not a person reading your messages, and not a list of banned words. A trained set of values, backed up by a live security layer watching for the gaps. Hope this cleared things up. See you in the next one.